Okay, in this video, we are going to do a couple of examples. I'm going to do both examples using both methods side by side of the two ways that we've learned how to factor quadratic trinomials. One way that we've learned is the Berry method, and the other way that we've learned is the area method or box method. Okay, so here we go. Here is our first trinomial that we're going to do. It is x squared plus 12x plus 20. Okay, so let's take a look at what we've got. We've got two plus signs, so because C is plus and B is plus, we know that both of the binomials have to be positive, okay? So let's set up our two parentheses, and on the other side, we'll set up our area model, all right? Remember, one of the terms, one of the binomials is going to get written here, and the other one is going to be written up here. So let's start this method, the Berry method. We know that both of these are going to be positive. We've already determined that. So what's our first move? We know that because A is equal to 1, that this one's going to be x and the other's going to be x, because when you multiply x times x, you get x squared. So let's look at our A times C. That's the next step, right? So A is 1. So 1 times 20 is 20. So let's list the factors of 20. We've got 1 and 20. That's not going to work. We've got 2 and 10. Ooh, look at this. We want our two factors of 20 to add up to 12. And look at what we've got. So I think we are done looking for factors. So I'm going to write 2 over here and 10 over here. And I think we've got ourselves a problem. Let's check. X times x, x squared. X times 2, 2x. 10 times x, 10x. And 10 times 2 is 20. Combine like terms. Yay! Look at what we ended up with. We ended up with the same trinomial that we started with, which means that this is our correct factored form. So now let's do the same thing over here for the area method. Now recall, the area method, we write the A term in the upper left, so that's going to be x squared. And we're going to write the C term in the lower right, so that's positive 20. So now, once again, we do the same procedure that we did for the Berry method, where we are looking for factors of 20, A times C, that equal, when you add them together, that they equal 12. And we already determined that they are 2 and 10. And once again, I would like to remind you, it doesn't matter. It does not matter which you write in which box. So this time I'm going to go straight across again. So what is the greatest common factor between these two terms? It's x, right? So when I divide x squared by x, what do I have left? X. If I divide 10x by x, what do I have left? Positive 10. So now let's do the bottom. If I have x up here and I divide by 2x, what do I have left? I have 2. And here you have it. We're already done. So let's check our answers. We have x times x. Well, that's absolutely x squared, right? We've got x times 2, that's 2x. We've got 2 times 10, which is positive 20, and x times 10, which is 10x. So yay, we ended up getting the same exact answer. But let's see what happens when a is greater than 1. All right, that's a little bit different. The basic procedures are still the same for both methods, but you have an extra step in the vary method that you don't have in the area method. So here's our trinomial, sorry, that has 6x squared minus 11 minus 2. Okay, so for the area model, we are going to draw our box with our 4 little boxes. Remember that one of our binomials is going to be written along the side, and the other one is going to be written across the top. Over here, we're just going to put our 2 binomials. All right? So we're going to follow the same procedure that we started with in the other type of problem. In that, we are going to write our A term in this box, our -2 down here in the C box. So now let's figure out where we're going to start. A times C is -12. So I am looking for factors of -12 that add up to -11. Okay? Factors of -12 that add up to -11. Well, let's just start listing the factors of 12. Okay? We have 1, 12, and we have 2, 6. Right away, I can see that this isn't going to work. This is what I'm going to want to work with, this 1 and this 12. So let's take a look at our side, shall we? This is negative. My C is negative. So what that tells me is I am going to have 1 positive binomial and 1 negative binomial. And because B is also negative, that means that the larger of the 2 factors is going to be negative. So if I have a -12 and a +1, when I multiplied those 2 together, I would get -12. And if I added them together, I would get -11. So let's go ahead and do that. All right. So I've got -12 here, and I've got +1 here. So let's do the same thing here. I've got -12x here, and I've got +1 or +x. There. So this is where it gets a little different, okay? So what's the greatest common factor between these two here? Let's do the area model first. So between 6 and -12, 6x and -12, I'm going to choose 6x. Okay? 6x squared divided by 6x gives us an x left. Correct? And negative 12x divided by 6x gives us negative 2. Okay? Likewise, let's finish the problem. If I have an x over here and I divide it by itself, what do I have left? I have a positive 1. And if you check yourself with all of these multiplications, they come out right. Okay? Almost done here. So you can see that my two binomials are going to be 6x plus 1 times x minus 2. And if you multiplied this out, you would see that when you multiply these two together, you get negative 2. Okay, so C turns out right. And negative 12x plus 1x does give you negative 11. So let's see how we solve this and get the same answer using the Berry method. So in this case, what you do is you write 6x in both binomials. Okay? And you look and see whether you can simplify the binomials any further. So here you have 6x plus 1. There's nothing else you can divide out of this binomial. And as you can see, this matches the other method. So you know that the 6 is going to go in this binomial right here. So let's take a look at this one. Well, I can divide 6 and 12 by 6. And what does that give me? It gives me x minus 2. So you see that after that little bit of simplification, we ended up with the exact same answer. So this is how you go about dividing or splitting apart a trinomial that has a greater than 1. Two methods, both work equally well. So thank you guys for listening and see you in the next video.